You'll see this a lot in Android applications, and in many, if not all, of the Android applications that we deal with from here on in will be multi-threaded because we have something going on while the application is waiting there for the user to do something, user to interact. There's a little safeguard built into the Android operating system that if the user does something to the screen and nothing happens, the gesture isn't handled, then if that lasts for a certain amount of time, Android will actually pop up an error message and say the application isn't responding. So it's a priority for an application to be able to respond to the user's gestures and user interface interactions. If not, Android assumes something's wrong. So if we have something else, in this case our screen being drawn, in other examples it might be running out to the internet to get some data. That would be an example of a process that would take a while. Any of these processes that sort of take a while to happen, we're going to put in a separate thread so the application can still handle the user interface. If you think about it, for the tip calculator, this wasn't something that was particularly necessary, right? Because the calculation of a tip, where we take the value from a text box and value from some drop downs and so on and do a little calculation, that's not going to be time intensive at all. That's going to happen like that. So there's really no need to create a separate thread for that, because the single thread can absorb that little piece of code without affecting how the application is responding to the user's actions. In the case of drawing the screen, though, that is something that does take some time, and therefore we're going to make sure that it has its own thread. I'm going to bring up the code for this. Then I'm going to go and grab the device because I forgot the device this morning. And we'll actually look at the code that does this. Again, I think it's important to understand this on this perspective so we know exactly what's going on and how having multiple threads is different than having multiple processes. Here is our thread. So take a minute, look at this code while I go grab the device. And I'll be back in a minute. revisit this throughout the semester. So if you are confused about some things, we will go and revisit this and hope that each time that we talk about it, it gets a little clearer. The level I'm interested in you understanding it now is, first of all, the need for threads. All right? And again, the need for threads is because within one application, we need several things to be going on at the same time. And typically within an Android application, one of those things is listening for the user's input, listening for the user's interaction. And then the other thing are things that take a while that could potentially take away from the application's ability to listen to or listen for the user's interactions. Understand the difference between a thread and a process. How a thread runs within a process, and each thread within that process can access items within that process's space, memory. All right, here's this, and I think I pointed it out before, but to revisit this, notice that is constantly moving, and the fact that I go and do some things doesn't affect the fact that it's constantly moving. All right? If this is not done with multiple threading, as I interacted with the screen, the motion of the target and the blocker would likely stutter a bit. All right? Because again, you can only do one thing at a time. If everything's in the one thread, then everything about this application could only happen one thing at a time. By separating into multiple threads, we can allow the drawing of the screen and the interaction of the user to happen at the same time. All right. Let's look at the code for this. First of all, notice that we have a class called CannonThread, which extends thread. All right? We have to make a thread. Threads that we make are going to be inherited from the thread superclass. This has one constructor, and that constructor takes an argument of a holder, and we'll see what that is in a second here. We have a couple of method calls to methods in the ancestor, such as setName and setRunning, so that we can stop and run this thread as we need. We then have a method that we're overrunning that is called run. That we're overriding, rather, that is called run. This is the code that runs while the thread is running. So let's see what this happens when this code is running. All right? We have a while loop, so this is going to repeat over and over and over again. All right? The screen doesn't just draw once, it draws repeatedly over and over and over again. So that's contained in a while loop. We then have a series of methods that this is doing, and they're synchronized. Synchronized means that this chunk of code is going to execute, how do I want to put this? Not multiple threads can't be executing this code at the same time. So this code is only going to execute once at a time. And if I'm not mistaken, it's going to execute uninterrupted. Not entirely sure of that. No, that I don't believe that to be true. I think synchronized simply means that this block of code can only be running one time. And we're going to do these things. And what do these things involve? These things involve displaying the elapsed time, displaying the time is left. And then calling these two methods to update the position and to draw the game elements. Update position goes and calculates where everything ought to be. Calculates where the cannonball is to be. It looks to see if there's been a hit. And then it moves the blocker and the targets. It also checks to see if there's any time left. If there's no time left, it says that it's over. So notice, this code is in. This code is in the Cannon thread. And when this thread is run, lost track of. Here we go. When that thread is run, we're looping as long as this thread is running, and we're calling that update positions. So that update positions is running constantly. So it's constantly looking to see if we fired a cannonball. Because if we fired a cannonball, it's going to draw and move that cannonball. It will also, no matter what, then move the target and move the blocker back and forth. Finally, when we're all done and the time has gone down to 0, it will tell us that the game is over and ask us if we want to play again. I'm less concerned about the details of what happens and how it moves the different things than the structure of the way this thread works. We're in a loop here. And again, think if this was not threaded. If this was not threaded and we were executing this loop, as we're moving back and forth, that code to move the stuff would be executing, but would never execute any of that code to respond to the user actions. All right? This would be essentially caught in like an infinite loop, and we would never respond to the user action until the game was done and we left the loop. Instead, though, this is run as a thread, which means it's going to get little pieces of this process's time. So as the machine, as the processor is switching between all its processes, when it comes to this process's turn, this process will further split the time between the two threads. The one thread that's listening for the user input and the other one that's displaying the screen. We calculate where everything should be, and then in the draw games method, we actually draw game elements. We actually draw the different things. So we start out, we clear the background, we display the remaining time, we display the cannonball if it's on screen, we draw the cannon, we draw the blocker, and we draw the target pieces. So this code is executed over and over and over again in the loop, and therefore it's constantly figuring out where the position of things are and displaying them, while the other thread for this application is waiting for the user's on-touch events. So a general rule for threads here is if you have anything that could potentially distract your application from the user's interactions with the application, it ought to be in its own thread. And in this case, drawing the screen and moving those things back and forth needs to happen constantly. If that were not its own thread, it would happen constantly, and it would compromise the application's ability to actually detect, hey, someone touched the screen, or someone double tapped the screen, or whatever. And therefore, it becomes a separate thread. Questions on this? For one of your assignments, I forget the number that we're on, but your task is to make a little sound toy that's going to play certain built-in sound effects. Phone sort of sound effects like the dial tone and the busy signal and all that stuff based on the user's gesture. In that case, it's similar to this. The actual playing of the sound and running the animation, I think I asked for as well, to create a little animation that runs. All right. These things need to happen at the same time as the application is listening for user gestures. Therefore, it needs to be its own thread. Each of these applications we go over again are meant to not just illustrate the stuff that's in the application, but bigger principles as well. And the bigger principles in this application would be, number one, we're using a custom view. And then number two, we're using multi-threading to get our job done. I think I mentioned before that there's a couple things I didn't like about this application. One of them being that the align cannon method actually does two things. The align cannon actually tells me the angle that it's aimed at and re-aims the cannon to the point where it was touched. Actually, it does that one first and then does the second one. So it points the cannon where it was touched, and then it determines the angle that the cannon is at. And that angle is used by those draw methods to draw the cannonball as it moves across the screen. What is wrong from that what's wrong for that is this doesn't allow any way for us to change the application to shoot without aiming. All right? And that could be seen as a flaw. This method isn't just an align cannon method. This method is align cannon and tell me the angle that the cannon is at method. It does those two things. When you're creating a method, if the method name has two parts like that, where a method actually does two things, very nearly always you're better off splitting it into two methods. Because you might not always want to do both those things together. All right? That's sort of a basic programming notion. That a function should be really focused on doing one specific thing. This function, because number one, it aligns a cannon, and then number two, it tells me the angle that the cannon is pointing at, actually is doing two things. And the downside of that is we're not able to separate and call the one without calling the other. I believe I fixed that in a version that I created. Let me take a look. I actually took that one method of align cannon and I broke it up into three methods. Each of which does just one thing. The align cannon simply aligns the cannon. What do I mean by align the cannon? I mean when I touch the screen, it points the cannon to that part. It doesn't return the angle or anything like that. I have a separate getAngle function that tells me the angle that the cannon is aimed at. And I have a separate position barrel method to go and position the barrel where that was in. That was all combined into one method, all right, before, the align candle method. Let's see the advantage of that. And the advantage of that is that I've added some flexibility to this application. I've added the ability to handle a couple different gestures and do a couple of things that were not easily accomplished in the original version. I added a gesture. Now, single tap does what it did before. It aims the cannon. Double tap also does what it did before. It aims the cannon and shoots. but a swipe shoots without aiming. All right? So, that would have been very difficult for me to accomplish with the code the way it was written before. This is a great example in my mind of why code that works isn't necessarily good code. That original example was code that worked. It played the Cannon game the way that it was intended to be played. The problem is that it was hard to change, to add some new features to it and new functionality. Why was it hard to change? It was hard to change because that align cannon method wasn't a well-designed method. It was a method that actually combined a couple different activities. And therefore, I needed to go back and change that method. And now that I've changed it, I can go and add the extra gesture. This process is known as refactoring, where you take code that works and make it better. Generally speaking, what makes it better? When it's more maintainable. And often what you do is break down a big task into smaller tasks. When you have a big task, you have to do the whole task every time you call that method. By breaking this down into little mini tasks, I can pick and choose which tasks I want to do. That makes it easy for me to just aim the cannon, to aim the cannon and shoot, or to just shoot. Because all that stuff was combined into the one method before, it's very difficult for me to do that. So when I broke it down to that, what I could do then is I could expand the gestures so that when I do the swipe, or the fling rather, it just fires the cannonball. When I do a double tap, actually first the single tap code fires off to aim it, and then the double tap code fires off for me to actually shoot it. So a double tap will actually first call this, and then call that. So I get the aiming and then the shooting. Whereas the swipe, I don't get the aiming because that's a different sort of gesture. The other thing I did that I think marks an improvement for this is I've put all the processing of gesture in the gesture listener. If you remember in the original example, some of the